lesson, we're going to look at the difference between independent and dependent probability. So probability is defined as the number of favorable outcomes out of the number of total possible outcomes. So looking at this spinner here on the left, I could ask you, so what's the probability of the spinner landing on a green sector? Well, that would be equal to, I see 2 green sectors out of a total of 8, so it would be 2 8s, which reduces to 1/4. And probability can also be written as decimals, so 0.25 or 25%. So fraction, decimal, or percent is acceptable. Sometimes it's helpful to look at the sample space with probability, which is just a listing of all possible outcomes. So if I asked you for a die, what is the probability of rolling a 2? Well, there is just 1 2 out of a total of 6 choices, which most of you can probably do in your head. But if I ask you something a little trickier, like what's the probability of getting a prime number? Well, which ones are your primes? Hopefully you know that 1 is neither prime nor composite, 2 is prime, 3 is prime, 4 is not, it's composite, 5 is prime, and 6 is composite. So there are 3 favorable outcomes out of a total of 6, which is 1/2, 0.5, or 50%. The probability of an event occurring is always between the numbers 0 and 1. Few things in life are 0 or 1. Most things fall somewhere in between here. Even if I say, what's the chance it's going to be sunny on a given day, you might be pretty sure that there's no rain in sight, but maybe some fluke cloud comes up, so 98% chance of sunshine. Okay. Let's make this a little bit tougher. Let's talk about compound events. So we have 2 types of compound events we're going to look at, independent versus dependent events, and it's pretty simple here. So independent is where the outcome of one event does not affect the outcome of another. Like if I flip a coin or I roll a die, what I get when I flip the coin doesn't affect what I get on the die. They're independent of one another. So the way you calculate independent probability is you can look at the 2 probabilities separately and you just multiply them together. Okay? So if I said, what's the probability of getting a heads on a coin and a 1 on a die, you would just do the probability of a heads is 1/2 times the probability of getting a 1 on a die is 1 out of 6. So 1 times 1 is 1 and 2 times 6 is 12. So your chance would be a 1/12 chance. Dependent probability is a little more complicated, okay? This is where the outcome of one event does affect the outcome of another. So what type of things in real life work like this? Well, think of a deck of cards. If I take out a card, I've changed what's in the sample space. So if I'm playing a card game and I want to know what's my chance of getting a queen of hearts, there's only 1 queen of heart in the deck. If I draw it out, I've changed how many cards are in the deck. Now there would only be 51. So the probability of A and B is still going to be multiplication, but you're going to have to think about the probability of getting B following A, like it's already happened, following A has occurred. So I'm going to illustrate this with an example. Using the bag of marbles on the left, what is the probability of pulling a white marble 2 times in a row? So probability of white and white. So we're going to look at this 2 different ways. So the first scenario is I'm going to say, you know what, I'm going to put that marble back in after I draw it. All right, so this would be independent because what I get the first time, if I shake that bag around, what I pull out the second time, they're not impacting one another. So here's how I'm going to write that. I'm going to say probability, capital P, of white and white. And sometimes you might just see W and W is equal to, well, what's my chance of getting the first white? I see 4 out of how many total are in the bag? I see 10 marbles in that bag, okay? You're gonna multiply that by, again, you put that marble back in, so there's still 4 and there's still 10 in that bag. All right, you can multiply straight across. That would be 16 out of 100, which reduces to 4/25. And you can change that to a decimal if you want, or just leave it as a reduced fraction. Okay, Now let's look at, well, what if I draw the marble and I don't put it back in? Okay, how does that change my probability? So what I do now is my chance of drawing the first one is still 4 out of, I see a total of 10. Okay, but now I'm assuming that I pulled out a white one, so I'm going to cross one of them off. Now there are only 3 white marbles in the bag, and there's a total of 9 because one is out of the bag. So I'm still going to multiply this, but you notice that my sample space has changed. All right. So I multiply straight across, that's going to be 12 over 90, which is going to reduce to, think 4 over 30. Just a reminder of reducing fractions. Let's see, 3 goes into both, right? Yep, so it goes in 4 times, and 3 goes into 90 30 times. So 4 over 30, and I think that reduces even further. 2 goes into both of those, so 2 over 15. So 2/15 is my final answer. All right, in the next example, it says 2 number cubes are rolled. That's a fancy way of saying dice. So 2 dice are rolled. What is the probability that both numbers are less than 3? So I want to know the probability that the first number is less than 3 and the second number is less than 3. So think, when I roll the first die, does that affect the second die? No, okay? So this is going to be independent. So all I need to do is find these 2 probabilities separately and multiply them together. So less than 3, well, that would be a 1 and a 2. I'm just going to write out my sample space for a second. So my successes, 1 and a 2, are less than 3. So there are 2 of them out of 6. And again, 2 out of 6. Now, multiply straight across, that's 4 out of 36, which reduces to 1/9, because 4 goes into both the top and the bottom. Okay, in the next one, in a bag, there are 4 yellow pencils, 9 blue, and 8 red pencils. Once a pencil is selected, it is not replaced. Okay, that right there, not replaced. You also see that set as without replacement. So this is going to be dependent. What is the probability that 2 blue pencils are chosen? So the probability of a blue and a blue, and I'm writing with a red pen, which makes a lot of sense here. Blue and blue. All right, so my chance of pulling out that first blue is 9, because there's 9 blue, out of a total of, well, you got to add them together. 9 plus 8 plus 4 is 21, and you're going to multiply that. Now, you assume that you're successful, so you take one out, and now there's only 8, and that means your total pencils in the bag have dropped to 20. So you're going to multiply straight across for fractions, which is 72 out of 420, and that's going to reduce to 6 out of 35. Just really quickly, I'm going to show you, since you're at home, that there is a graphing calculator that has a fraction button on it. If you go to desmos.com and select scientific, there is a fraction button, which is right there, the A over B. You can just tap that, and if you do, let's see, we said 9 over 21, times fraction button, we did 8 over 20. And if you hit, well, you'll see over here on the right, it gives you the decimal format. If you want the fraction, the beautiful thing is just tap the fraction button next to it, and there it gives you the reduced answer of 6 over 35. I hope you're using mental math, but I know some of you struggle with fractions, so there are online tools available for you. Okay, last one, it says you randomly draw twice from this deck of cards. What is the probability of drawing a G, then drawing a G without replacing the first card? So probability of G and G. Okay, it's going to be equal to, let's see, I see 2 G's out of a total of 6, 2 out of 6, times, now you assume you're successful, so one of them is gone, 1 out of, and there's only 5 cards remaining, so that multiply across is 2 out of 30, which reduces to 1 out of 15 for your probability. Okay, so you're going to do a Get More Math assignment where you practice with independent and dependent events. And as always, if you find you're struggling, please reach out to us with questions.